Welcome viewers, in this video we'll see the asynchronous 3-bit up counter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, asynchronous 3-bit up counter. So the up counter is nothing but here made up of flip-flop storage element. It will store 1 bit of data. So counter means it will count the numbers either 0 to n or n to 0. Up counter means 0 to n. So the 3-bit counter. So 2 to the power 3, there are 8 combinations will be there. Synchronous, asynchronous, 2 types available. Synchronous counter means all the flip-flop receive the same clock pulse. Asynchronous counter means first flip-flop receive the clock pulse. Second flip-flop, the clock pulse is nothing but output of the first flip-flop. Then output of second flip-flop is connected to the third flip-flop. Like that it will go. So the operation is not synchronized, so that it is called a asynchronous. Now we'll see the detail. A binary, ripple or asynchronous, both are the same. Counter consists of a series connection of complementing flip-flop with the output of each flip-flop connected to the clock input of the next higher order flip-flop. Right? So series of flip-flops are connected together. Complementing means it is the negative edge trigger. Inverted clock pulse. Inverted clock pulse is given, so that is given as complementing. So the first flip-flop receive the clock pulse. Output of first flip-flop is connected to the clock pulse of the second flip-flop, like that. So that it is given next higher order flip-flop. The flip-flop holding the least significant bit receive the incoming clock pulse. LSB, where the LSB is produced, that will receive the clock pulse. The complementing flip-flop can be obtained from a JK flip-flop. Here we are going to use the JK flip-flop. In that, J and K inputs tied together are shown in the diagram. Both J input and K inputs are same. Both are connected together. It will give the high output, logic high. J and K is connected together, get the same output as logic high. Now we'll see the diagram. Logic diagram of this 3-bit up counter. So this is the 3 JK flip-flop available. A, B, C. This is the LSB and this one is MSB. J and K is connected with the high input. All the inputs of J and K connected with logic high is 1. 1 is connected. Right? So in this JK flip-flop, if both the inputs are 1, what will happen? The output will toggle. Both the inputs are 0 means no change. Both the inputs are 1 means the output will toggle with every clock pulse. 0 means it will change to 1. 1 means it will change to 0. Previous state, next state, we know that. Previous state 0 means next state will be 1. Previous state is 1 means next state will be 0. When both J and K inputs are 1. That is the nature of the JK flip-flop. Now see the clock pulse is connected here for the first flip-flop. Inverted, complementing. Output of first flip-flop is QA, that is connected as a clock pulse of the second flip-flop. Here also inverted. The QB is the output of second flip-flop, that is connected to the clock pulse of the third flip-flop. This is also inverted. Right? So the first flip-flop receive the clock pulse. Second flip-flop, clock pulse is nothing but output of the first flip-flop. Third flip-flop receive the clock pulse, that is nothing but output of the second flip-flop. Right. Now we'll see what is the complementing the clock pulse. So let us consider this is the clock pulse. So this is the, when there are 2 types available, positive edge triggered, negative edge triggered. So this is called positive edge trigger. When the clock pulse is changes from, this is 0. Here signal is available, again 0. From 0 to 1, rising edge is called a positive edge triggered. When the clock pulse changes from 0 to 1, the signal will be applied to the flip-flop. So this is the negative edge triggered clock pulse. When the clock pulse changes from 1 to 0, falling edge. So at this time, the state will be changes. Right? The output of the flip-flop will changes every negative edged clock pulse. when the it is called positive edge. This is normal clock pulse is directly connected. Here complementing, the clock pulse is complement. Here we are connected with the complement, right? If it is directly connected, every positive edge the state will changes. Is connected with complementing, so every negative edge clock pulse the state will changes, right? So 0 to 1 positive edge triggered, 1 to 0 negative edge triggered. In this type we are using negative edge trigger, that is what we are complementing, right? Now we'll see how we are getting the 8 states of output. So the JK flip flop, J and K value is 1. So the every clock pulse, when the clock pulse is applied, when every clock pulse the state will changes. Every negative edge, the state of the first flip flop will change from 0 to 1, 1 to 0, like that it will change while receiving the clock pulse, every negative edge. Similarly here the QA is connected as a clock pulse. So whenever QA goes down, negative edge, the state of the second flip flop will changes. Then third flip flop is connected with QB, second flip flop output. So whenever QB goes down, negative edge, the state of the flip flop C will changes, right? The state of the first flip flop changes when the application of clock pulse during every negative edge. The state of the flip flop B changes when the QA signal goes the negative triggered, negative edged. The third flip flop state will changes with every change in the QB, that is during the negative edge, right? So based on that we'll go for the clock diagram and we'll see the what are the possible 8 outputs are available. So this is the clock pulse given. There are 8 clock pulse available. So this is the output QA, LSB, QB and QC. QC is MSB, least significant bit. This is most significant bit. So this is the count and stages. So 0 to 7 there are 8 stages available. The count is from 000 to 111. We need to get from 000 to 111, right? Now we'll see how we are getting the output. You need to check QA, QB and QC. So the QA is the first clock pulse, first flip flop. For the first flip flop the clock pulse is applied, right? So this is the negative edge. This is the negative triggered. Whenever negative triggered, the state of the flip flop will changes, right? So this is positive edge, positive triggered, but now we are using negative edge. Whenever the clock pulse changes from 1 to 0, 1 to 0 the state will changes. See here, initially all are 0. Here the negative edge is there, so 0 is changed to 1. Again this is positive edge, so no change. So during negative edge, the changes, the output of the flip flop changes from 1 to 0. Then during the third clock pulse, negative edge, the output changes from 0 to 1. During the next negative trigger, 1 to 0. During next negative trigger, 0 to 1. During next negative trigger, 1 to 0. Then 0 to 1. Then 1 to 0. Right? So the clock pulse is applied to the first flip flop. So whenever there is a negative edge, the state changes from 0 to 1, 1 to 0, 0 to 1, 1 to 0, like that. Right? 0, 1, 0, 1, it is going. Right. Now this signal is applied as the clock pulse of the second flip flop. Right. So now clock pulse is applied to first flip flop. The output of first flip flop is the clock pulse of the second flip flop. So whenever there is a negative edge, so this is the negative edge. This is positive edge. Similarly, this is positive edge, this is negative edge. Changing from 1 to 0. 1 to 0 is the negative edge. Similarly here, 1 to 0, negative edge. 1 to 0, negative edge. So whenever there is a negative edge, the state changes from 0 to 1. Until the next negative edge, the 0 will be maintained. Right? Here, one is that this is the positive trigger, the no change. Positive trigger, we are not, the state will not change. During negative triggered only, negative edged only, the state will change. So here initially 0, during positive edge triggered, there is no change. During negative edge triggered, the 0 changed to 1. During positive edge, no change. During negative edge, 1 is changed to 0. Then no change. Again next negative trigger, 0 changed to 1. Again it is 0. Right? So whenever negative edge, 0 changed to 1. Whenever negative edge, 1 changed to 0. Here 0 changed to 1. Like that it goes. Right. Now this clock pulse, this signal is given as a clock pulse for the third flip-flop, QC. Right? See, this is the negative edge. This is positive edge. 0 to 1 is positive edge. 1 to 0 is the negative edge. Similarly, this is 0 to 1 positive edge. 1 to 0 is the negative edge. So the state will change during this negative edge only. During positive edge will not change because we are connected complement. See, it is 0. Here positive edge, no change. Here negative edge. So the 0 changed to 1. So same thing will continues. Here positive edge, so no change. This is the next negative edge. So at this 1 now changed to 0. Right? So here 0 to 1 is changed. Here 1 is changed to 0. 2 changes occurs. Right? So these 4 stages 0, another 4 stages 1. Now we'll see the output of this. Initially all are 0 0. Then 1 0 0. Starting from, I am reading from LSB. 0 1 0. 1 1 0. 0 0 1. 1 0 1. 0 1 1. 1 1 1. Right? So we are getting the 8 different stages, 3-bit output. So 2 to the power 3, 8 outputs are, 8 possible outputs are available. Right? 0 0 0, I will read from MSB now. 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Right? So we are getting the all possible 8 countings are available. Right? I will explain again. So the first flip-flop, the clock pulse is applied. So during every negative edge, state is changes. This signal is applied as a clock pulse to the second flip-flop. So during every negative edge, the state changes 0 to 1, 1 to 0. This signal is applied to the clock pulse for third flip-flop. So during every negative edge, the state changes 0 to 1, 1 to 0. Now we'll see the description. So what we discussed, the description is available. Diagram shows 3-bit asynchronous counter using JK flip-flop. As shown in the diagram, the clock signal is connected to the clock input of only first stage of flip-flop. The clock pulse is given to only the first flip-flop. The clock input of second stage flip-flop is triggered by QA, output of the first flip-flop, of the first stage, and so on. So the first flip-flop, clock pulse is given, second flip-flop is output from first flip-flop, thereby it is keep on connecting. Then, because of the inherent propagation delay time through a flip-flop, a transition of input clock pulse and transition of the QA output first state can never occur exactly at the same time. So the first flip-flop depends upon the clock pulse. Second flip-flop depends upon the output from first flip-flop. So the transition of output of first stage and next stage never occur at the same time. Right? The first flip-flop will produce the output, thereby only the second flip-flop will produce the output. That is the given here. Thereby flip-flops are never simultaneously triggered, which result in asynchronous operation. So it is not triggered simultaneously. One by one it is triggered, so that it is asynchronous. The timing diagram for 3-bit asynchronous counter is shown in the diagram. What we discussed, the timing diagram we already discussed. It illustrates the changes in the state of the flip-flop output in response to the clock. That also we discussed. J and K input of JK flip-flops are tied to logic high, hence output will toggle. We know that JK flip-flop, both the inputs are high, means the output will toggle for each negative edge of the clock pulse. Because it is connected inverted, we discuss negative edge, that is from 1 to 0. Right. Now we'll see the stages one by one. Initially QC, QB, QA are 0 0 0. This is LSB, this is MSB. For the first negative clock edge, what happened? 0 0 1, right? A changes to 1. Second negative clock pulse, now this will become 1, right? This 0 become 1. Now it is 0 1 0. In the third negative clock edge, it become 0 1 1. Fourth negative clock edge, it become 1 0 0. Fifth negative clock pulse, it become 1 0 1. For sixth negative clock pulse, it become 1 1 0. Finally, seventh negative clock pulse, it become 1 1 0. And 1 1, it is triple 1. This goes to triple 1, right? So at every stages we are getting the states of changes, we are getting 8 combination of output. So in this video we discuss about the 3-bit up counter, asynchronous 3-bit up counter. We discuss the logic diagram, timing diagram and description, and stage by stage what happened in the stages of the output. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.